This is an introduction to the rare event rule for inferential statistics. As you can read, the question is rolling a 7 unusual or rare? Of course not. If you recall from our previous sections, rolling a 7 is the most common result when you roll a pair of dice. What if you roll the dice twice, or 3 times, or 4 times? Is it rare or unusual to get all 7s? There is a statistical rule to determine if an event is rare. It's called the rare event rule for inferential statistics. Read the definition. Here's an example. Suppose we assume we have a pair of fair dice. This is our assumption. Now suppose we roll the dice 6 times and it comes up 7 each time. This is our observed event. We now need to find the probability of rolling a pair of dice 6 times and having it come up 7 each time. First, we'll find the probability of rolling 1 7. We know there's 6 ways to roll a 7 when we have studied for the problem before. The sample space for this was 36, the number of different ways to roll a sum from 2 to 12. Our probability then is 6 over 36, or 1/6. Now we can use the multiplication rule to find the probability of rolling 7 6 times in a row. 1/6 for the first roll times 1/6 for the second roll. We continue till we have 6 multiplications. This is 1/6 to the 6th power, or 1 over 46,656. This is a little cumbersome, so we'll change it to a decimal, 200 thousandths. I think we can agree this is a very, very small probability. So according to the rare event rule, since the probability is small, the assumption that the dice are fair is incorrect. There is a problem. We need a value, a cutoff point. Everything above the value would not be unusual. Everything below unusual or rare. That value is 0.05 or 5%. Every probability equal to or above 5% is not unusual. Every probability below 5% is unusual or rare. Let's look at one example. Read the example. This is a relative frequency probability, so we can use the following formula. Read the formula. So the probability is 144 divided by 1,354. It reduces to 72 over 677, or we can write it as a decimal, rounded to 3 places. 0.106 or 10.6%. This value is greater than 0.05 or 5%. So selecting an orange M&M out of 1,354 M&Ms is not unusual.